Welcome to Susan's Learning Room. CBSE Class 10 Mathematics Chapter 2 Polynomials. CBSE Class 10 Mathematics Chapter 2 Polynomials. So we already studied introduction part, geometrical meaning of zero of a polynomial and all. Now we can discuss example and exercise. Okay. Example 1. Look at the graphs given below. Each is a graph of p of x where p of x is a polynomial. For each of the graphs, find the number of zeros of p of x. I am repeating once more. Look at the graphs given below. Each is a graph of p of x where p of x is a polynomial. For each of the following graphs, find the number of zeros of p of x. Here, we need to find number of zeros by looking at the graphs, right? Okay, first question. Just look at how many points this graph intersect the x-axis. Here, only here, right? So number of zeros, 1. In this case, it intersects x-axis at 2 points, right? 2. Number of zeros, 2. In this case, it intersects the x-coordinate 1, 2, 3. Number of zeros, 3. So just look at the intersection points, that is where the graph intersects the x-coordinate. Here, this point, the number of zeros 1, number of zeros 1, 1, 2, 3, 4, number of zeros 4. Okay, so you have completed the example 1. Now we can go to exercise. Exercise 2.1, first question. The graphs of y equal p of x are given below. For some polynomial p of x, find the number of zeros of p of x in each case. Okay. The graphs of y equal p of x are given below. For some polynomial p of x, find the number of zeros of p of x in each case. Here no 0, right? Here no 0. Here 1 0. Here 1 2, 3. 3 zeros. Here 1, 2. 2 zeros. Here 1, 2, 3, 4. 4 zeros. Here 1, 2, 3. 3 zeros. So by just looking at the graphs, we can plot the number of zeros, right? Relationship between zeros and coefficients. Relationship between zeros and coefficients. Okay. Here, first case, linear polynomial. Let k be the zero of the linear polynomial ax plus b, where a not equal to 0. Then, k equal, that is the 0 equal, minus b by a. That is, minus of constant term divided by coefficient of x, right? This is the first case. In the case of linear polynomial, if k is a zero of the linear polynomial ax plus b, where a not equal to 0, then k equal minus b by a. That is minus of constant term divided by coefficient of x. Next one, quadratic polynomial. Let alpha and beta be the zeros of the quadratic polynomial ax square plus bx plus c, where a not equal to 0. Then here alpha plus beta, that is sum of the zeros equal minus b by a. It's minus of coefficient of x divided by coefficient of x square. And now alpha beta equal, that is product of the zeros, alpha beta equal c by a. That's constant term divided by coefficient of x square. Okay, these are the case of linear polynomial and quadratic polynomial. Now we can go to cubic polynomial. Let alpha, beta and gamma be the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, where a not equal to 0. Then sum of the zeros, that is alpha plus beta plus gamma equal minus b by a, that is minus of coefficient of x square divided by coefficient of x cube. Now, sum of the product, it is alpha beta plus beta gamma plus gamma alpha equal C by A. It is coefficient of x divided by coefficient of x cube. Now, product of the zeros, it is alpha into beta into gamma equal d by A equal constant term divided by coefficient of x cube. So these are very important for the problem solving. So if we are given a polynomial, we need to find this number of zeros. We can use this formula to find the relationship between the zeros and the coefficients. We are doing example number 2. Okay, example number 2 from the text. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and coefficients. Okay, let us find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. Here, firstly we need to find the zeros. Next, we have to state the relationship between the coefficients and the zeros. Okay, so firstly we can write the p of x that's given. It is x square plus 7x plus 10. Okay. Now we can compare this given quadratic polynomial with the general form. On comparing the given equation with the general form, that is ax square plus bx plus c. So when we comparing the coefficients comparing firstly of the x squares, here a equal 1, right? Here it is 1, a equal 1, b equal 7 and c equal 10, right? A equal 1, here compared x square, here x, and here the constant term. So we got a equal 1, b equal 7 and c equal 10. Now we can split the middle term. Splitting the middle term, for that we can split it. For that we need to get the product, right? We need to get the product as 1 into 10. 1 into 10, that is 10, positive 10, and sum as 7, right? Now we can factorize this term 10 and we got 2 and 5 as the factors. So here the greater number is 5 and smaller number is 2. We can split the middle term, that is x square plus, instead of 7x, 5x plus 2x plus 10. Now x taking common, x plus 5 plus 2, again x plus 5. Okay, now we can take common from here, that is x plus 5, x plus 2. Okay, equating to 0, equating this with 0, we get x equal minus 5 and x equal minus 2. So we got the zeros, that is alpha equal minus 5 and beta equal minus 2. Now we can state the relationship between the coefficient and the zeros. So here firstly alpha plus beta, which is equal to minus 5 minus 2 equal minus 7 by 1, which is equal to minus b by a, right? Here b and here a. Now alpha into beta, which is equal to minus 5 into minus 2, which is equal to 10 by 1. Here we are just writing 1 because denominator is no denominator, so we are writing it as 1, which is equal to c by a. C is 10 and a is 1. So here we have stated the relationship, and also we have firstly we have find out the zeros and they have stated the relationship between the zeros and the coefficients. Okay. So we are doing example 3, that is find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. I am repeating once more. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and the coefficients. Here we need to find the zeros and then we need to verify the relationship between the zeros and coefficients. So firstly, p of x equal x square minus 3. We can compare, on comparing the given equation to the general form of quadratic polynomial, that is ax square plus bx plus c. You can write a equal 1. It's a coefficient of x square and b term will be 0 because there is no x term, and c equal minus 3. Right? Now, when we look at this equation, this is similar to a square minus b square, right? Which is equal to a plus b into a minus b. So here we can write this as x plus root 3 into x minus root 3, and we got the zeros. That is x equal minus root 3 and x equal plus root 3, right? Okay, now we can verify the relationship. That is, we can verify the relationship between the zeros and the coefficients. Firstly, the zeros alpha. Alpha is minus root 3 and beta is positive root 3. Okay, now alpha plus beta equal minus root 3 plus root 3 equal to 0. 0 by, can write 0 by 1, which is equal to minus b by a. Since it is 0, it can be equal to minus b. B term is 0, right? Now alpha into beta is equal to minus root 3 into root 3 equal minus 3, or minus 3 by 1 equal to c by a. So here we have, firstly we have find out the zeros, and nextly we have state the relationship between the zeros and the coefficients. So we have completed this problem. Now we can move to the next problem. Okay, so we are doing example number 4. Okay, we can read the question. Example number 4. Find a quadratic polynomial. The sum and product of whose zeros are minus 3 and 2 respectively. I repeated the question once more. Find a quadratic polynomial. The sum and product of whose zeros are minus 3 and 2 respectively. So here in the previous questions, it is given, the polynomial was been given, and we need to find the zeros and we need to state the relationship between the coefficient and the zeros. But in this question, it is alpha plus beta. It is sum of the zeros and alpha into beta is given. We need to find the quadratic polynomial. Okay. Firstly, alpha plus beta equal minus 3. We can write it as minus 3 by 1. We can compare this with minus b by a. Okay. Now, 2 can be written as 2 by 1 and can be compared with c by a. Then we get a, b and c. A equal 1, b equal 3, minus 3 equal minus b, and c equal 2. So we got a, b and c. So we can write the quadratic equation x square plus 3x plus 2. We can do the same problem with more easier way. The more easier method, that is, we know alpha plus beta. This is another method, right? Another method. Alpha plus beta equal minus 3 and alpha beta equal to. Now we know the general equation form x square minus alpha plus beta x plus alpha beta. Just substitute the value of alpha plus beta and alpha beta in this general equation. It's x square minus 3x plus 2. X square plus 3x plus 2. So the both way we can find the quadratic polynomial, but this is more easier way because there will be no confusion over the negative sign. Here there can be confusion over the negative sign of b, but here there is no confusion, not at all any confusion, and we can get the correct answer in a more simple way. We can do in both ways, but this is more easier method. Okay. Example 5. Verify that 3, minus 1 minus 1 by 3 are the zeros of the cubic polynomial p of x equal 3x cube minus 5x square minus 11x minus 3, and then verify the relationship between the zeros and the coefficients. Firstly, we need to check whether the given values, that is 3, minus 1 and minus 1 by 3 are zeros of the given polynomial. Okay. So what is p of x? P of x given, that is 3x square x cube minus 5x square minus 11x minus 3. Right? This is a p of x and we need to check. Firstly we can compare with the general equation. Compare the given p of x with the general equation of cubic polynomial, that is ax cube plus bx square plus cx plus d. Now we can comparing a. Here in the place of a it is 3, right? A equal 3, b equal minus 5, c equal minus 11 and d equal minus 3. Okay, we just compared with the general equation. Now we can check whether the given numbers are the zeros of this given polynomial. P of 3. Replacing x by 3. 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. Right? 3 into 3 cube. 3 into 27 minus 5 into 3 square, that is 9, minus 33 minus 3. Right? Now 27 into 3. 7 into 3. 21. Right? 2 remainder. 3 into 2. 6. 6 plus 2. 8. So here 81 minus 5 into 9. 45 minus 33 minus 3, which is equal to 0. Okay. So any problem? Doubt? Here 45 plus 33 plus 3 equal 6 plus 5, 11, 1 remainder 8. 81. So it cancel out, answer 0. Now we can check the next number, p of minus 1. Here 3 into minus 1 the whole cube minus 5 into minus 1 the whole square minus 11 into minus 1 minus 3. Right? 3 into minus 1 the whole cube is 3 into minus 1 minus 5 into minus 1 the whole square plus 1 minus 11 into minus 1 plus 11 minus 3 equal to minus 3 minus 5 plus 11 minus 3. is again equal to 0. So this is also 0 of the given polynomial. Now the last one, p of minus 1 by 3. 3 into minus 1 by 3 the whole cube minus 5 into minus 1 by 3 the whole square minus 11 into minus 1 by 3 minus 3. Okay, here 3 into minus 1 by 3 the whole cube is minus 1 by 27 minus 5 into minus 1 by 3 the whole square is 1 by 9 minus 11 into minus 1 by 3 plus 11 by 3 minus 3. Okay. Now again 3 into minus 3 by 27 minus 5 by 9 plus 11 by 3 minus 3. Here minus 3 and 27 cancel out. So it can be written as minus 1 by 3 into 9, 27, right? So 1 by 9 minus 5 by 9 plus 11 by 3 minus 3. LCM 9. Okay. Taking LCM as 9 minus 1 minus 5. Here 3 into 3 9. So 11 into 3 plus 33 minus here the denominator is 1 into 9. So 3 into 9 27. Okay, it's equal to again 27 minus 27 by 9 equal 0. So we have proved that these are the zeros of the given polynomial. Now we can check the relationship between zeros and the coefficients. Firstly, alpha plus beta plus gamma. Okay, what are the alpha, beta and gamma? Alpha equal 3, beta equal minus 1 and gamma equal minus 1 by 3. Now alpha plus beta plus gamma equal 3 minus 1 minus 1 by 3. Taking 3 as the LCM. Here 3 into 3 9 minus 3 minus 1. It is 9 minus 4 by 3 equal 5 by 3, which can be written as minus of, right? This is equal to minus b by a. Is equal to minus b by a, right? This is equal to minus b by a. So first one we verified. Next one, alpha beta plus beta gamma plus gamma alpha equal 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3. Here minus 3 plus 1 by 3, 3 and 3 cancel out, minus 1. LCM is 3. Here 3 into 3, it is minus 9 plus 1 minus 3. Okay. Here minus 12 plus 1 by 3 equal minus 11 by 3. It's again equal to minus 11 is C, right? It's again equal to C by A. So this is equal to minus B by A and this is equal to C by A. So we verified the first two cases. Third case, that is alpha plus beta, alpha, beta, gamma, product of the zeros equal alpha 3 into beta minus 1 into minus 1 by 3. Answer equal positive 1. So we get confusion why it came positive 1. It can be written as like this, right? Minus of minus 3 by 3. Right? This is equal to minus d by a. So we verified the 3 cases. Okay. So we have done the question related to cubic polynomial. So I think in examination point of view, cubic polynomial is not needed. But we have discussed the cubic polynomial also. So that's all for today. Thank you.